This is class 13 of my arithmetic course. Today we're going to be multiplying and dividing fractions. Now up until this point, the math that we've been doing has been pretty straightforward. Even the algorithm long division and the algorithms for multiplying 2 and 3 digit whole numbers, and even adding and subtracting fractions, all those algorithms have been pretty straightforward. Most people would be able to figure out the algorithms pretty easily if they had some time. But this is the first class where the meaning of the algorithms is really not easy to figure out, because the interpretation when it comes to multiplying and dividing fractions starts to become really complicated. But the good news, like I mentioned before, is that the actual operations, the algorithms, are going to be easy to carry out, unlike the last class where the operations were somewhat involved. So let's go ahead and get right into it. And by the way, if you didn't do the homework from class 12, you're in the wrong place. Go back and do that homework. And also, if you haven't memorized your multiplication facts, go back and do that. So example number 1. 2/7 times 3. Now that's pretty easy to interpret, because when you multiply a number, that's just a different form of addition, right? So 2/7, we're just tripling 2/7. 2/7 plus 2/7 plus 2/7. Add all those up and you get 6/7, because you have a common denominator. But now when you go into example 2 here, things start to get weird already. Remember, we're using the commutative rule of multiplication, so we're just flipping this around. Or else, rather, we're going to prove that the commutative rule of multiplication works here. So what does it mean to take 3 and multiply it by 2/7? You're going to take 3 and it's going to become 6/7. So the number is actually going to get smaller. But you're multiplying by a number, and it makes the first number smaller. So that's counterintuitive, because usually when you multiply, you make the number bigger, right? But in this case, we're going to make the number smaller. So things are already starting to get weird. So how do we interpret this? Well, you've got 3 holes, because it's 3, right? And you're going to break each one of those holes into 7 parts. All right, so we have 7 parts, and we want 2/7 of each part. So you have 2/7 plus 2/7 plus 2/7. So we have 3 holes. 1, 2, 3. And we're finding 2/7 of each one of those holes. And that's what it means to multiply 3 by 2/7. You add all those up, we put plus signs here. And 2/7 plus 2/7 plus 2/7 is how many sevens? 6/7. So as you can see, that 2/7 times 3, that makes a lot of sense, but already we're starting to get into some stuff that is kind of weird, because we're multiplying by a fraction and making the number smaller. So now that's interpreted as finding a fraction of 3. So multiplying by a fraction is interpreted as finding a fraction of the number. We found a fraction of 3. 2/7 of 3 is 6/7. So that's how we interpret this in the real world. So now we go to multiplying a fraction by a fraction. Here, we just multiplied a whole number by a fraction, right? But now we're multiplying a fraction by a fraction, and things are going to get even more weird. Now, this is interpreted as finding 4/5 of 2/3. Let's say that your lunch is 2/3 of a pound of spaghetti. 2/3 of a pound of spaghetti. So this entire thing is 1 pound, even this part here. All these parts together is 1 pound. But you are given 2/3 of a pound of spaghetti. So you're only given this amount. That's your lunch, is 2/3 of a pound. Again, the entire thing is 1 pound, but you're given 2/3 of a pound. That's what you're actually given for lunch. But we all know that sometimes if we're not really hungry, we don't finish our entire lunch. So let's say that you only finish 4/5 of your lunch. So we take 4/5 of your lunch, which is the purple part. So we break it into 5 parts, because that's the denominator. That's what you're counting. fifths. So we have 1, 2, 3, 4, 5. We broke it up into 5 parts. And then you only ate 4 out of those 5 parts. So I'm going to color that in. 4 out of 5 of those parts. 1, 2, 3, 4. So that's how much you actually ate. So now here's the big question. Here's what we're looking for. What fraction of the whole pound of spaghetti did you actually eat? We're not looking for what fraction of your lunch you ate. We're not looking for what fraction of your lunch, because we already know what fraction of your lunch we ate. We already know it's 4/5. That's not what we're looking for. Okay? It's really easy to get confused with this stuff. We're not looking for the fraction of your lunch. That's 4/5. We already know that. We're looking for the fraction of the entire pound of spaghetti. So you were only given 2/3 of a pound, but what fraction of 1 whole pound did you actually eat? So we're looking for what fraction is the red part out of the whole thing, right? So what fraction is the red part out of the whole thing? So we can't figure that out unless we extend these lines. Now we can figure it out. So how many of the red do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. And how many total rectangles do we have? Well, we have the ones we already counted plus 9, 10, 11, 12, 13, 14, 15. Let me get rid of those. 15 in the bottom, 8 in the top. So 2/3 times 4/5 is 8/15. All right, now here's the important thing. Well, first of all, so how do we interpret the problem? Well, you ate 8/15 of a pound of spaghetti. Okay, you know that you ate 4/5 of your lunch, but the purpose of this problem is to figure out what fraction of a pound of spaghetti you ate, which is 8/15. So this is when I say that there's a lot of people out there, engineers, scientists, teachers, who don't understand what is going on here, this is what I'm talking about. You know, very, very few people are. If you talk to any adult and you ask them, what does this mean? They're going to have a blank stare on their face like you would not believe. Okay, I'm talking the highest people in society, politicians, the smartest people. Very few people out there have ever thought about this or even want to think about it. So if you're understanding this, then you're way ahead of the game. And I know a lot of people out there might think, oh, I don't. Is that really true that so many people don't understand it? Well, go out and test people, and you'll find out for yourself. Go ask engineers, go ask scientists, and don't let them just give you a short answer. Ask them to explain it, and then once they explain it, then think about it, what they said, and then think about if it really explains what multiplication of fractions mean. You're going to find, well, they didn't really explain it. They attempted to, but they didn't really explain it. And then you have to go back and ask them again, and pretty soon you're going to find out that it takes a while to figure it out, but finally you're going to get to the point where you realize, wow, people don't really understand this. And I don't really think about it either. I just do the operation, so I'm not saying I'm better than anybody else. I'm just saying I'm a teacher, so I'm trying to let you know what this stuff actually means. But in this class, we're going to find that a lot of the stuff that we're doing is the meaning of it is it's not exactly obvious. So here's the point. How do we multiply fractions? Well, notice we had for the red, well, first let's start with the whole thing. 15 represents all the rectangles, right? All the rectangles in the entire thing. So how did we figure out 15? Well, we have 3 columns, 1, 2, 3, and we have 5, how many? Yeah, we have 5 rows. So 5 plus 5 plus 5, that's 5 times 3. Did you catch that? 5 times 3. So to figure out the total number of rectangles, we just multiplied the denominators. All right? And I think you get the point here. To figure out the numerator of our answer, we just took the number of columns of the red part. There's only 2 columns for the red part. and then we multiplied that by 1, 2, 3, only 4 rows for the red part. So 4 plus 4 is the same thing as 4 times 2. So 4 times 2. So this is the good news. So far I've only been telling you really bad news in the sense that this stuff is hard to interpret as far as what it means. And a lot of people might say, well, why do we even need to interpret the multiplication? Well, mathematicians, they love to define everything when it comes to numbers, even when something is not really intuitive in the real world. If it doesn't really make sense in the real world, they still like to define it. That's the way mathematicians are. They just love numbers and they want to define, they want to give a meaning for everything, even if it doesn't necessarily have a meaning. So that's the good news, is that when you multiply fractions, you just multiply the numerators to get the numerator of your product, and you multiply the denominators to get the denominator of your product. All right, so fairly easy. But again, that problem with where you had spaghetti, that's how this would actually apply in the real world if you were to use this operation in these numbers. Now again, does multiplication of fractions really make a lot of sense? Not really, because when you multiply, you make something bigger. If you're multiplying fractions, you're making something smaller. Does the operation really translate? And the answer is absolutely not. It doesn't. So now we have to come up with all this new logic to try to figure out, or should I say lack of logic, to try to figure out what these operations actually mean. So let's go ahead and get into it. So we don't have to think about the actual real world with these problems so far. Let's just get into the actual operations. So 3/4 times 3/5. Very easy. 3 times 3 is 9. 4 times 5 is 20. 3 times 3 is 9. 4 times 5 is 20. You see how easy that is? Again, the concepts are difficult, but the actual operations are easy. Number 3, 1/6 times 1/8. 1 times 1 is 1. 6 times 8 is 48. So multiplying fractions is very, very easy. It's just applying it in the real world. That's where it gets difficult. All right, number 4. Why don't you try number 4? Pause the video, and when you come back, we'll do it together. All right, we're back. You should have got 15 over 28. 3 times 5 is 15. 4 times 7 is 28. If you didn't get the right answer, that's fine. Just go back and figure out what you did wrong. All right, number 5. Try number 5, pause the video, and when you come back, we'll do it together. All right, we're back. 1 times 2 is 2. 5 times 9 is 45. There you go. If you didn't do it correctly, go back and figure out what you did wrong. And on to the next problem. This one's going to be a little bit different. If we multiply across, 7 times 5 is 35. 9 times 7 is 63, but the problem here is this fraction can be reduced. It can be put into lowest, this fraction is not lowest terms. So we learned that in class, I think it was 11. Again, you always have to reduce your fractions. If you're an engineer or a scientist and you write your fraction as 35 over 63, then the other engineers and scientists are going to laugh at you because they're going to say, well, why did you do that? Why did you write it as 35 over 63? That's ridiculous. If you divided both sides by 7, then you would have ended up with 5 over 9. Isn't that much easier? Why didn't you just say you needed 5/9 of a gallon of water? Why did you say I needed 35 over 63 of a gallon of water? That just doesn't, why would you do that? So you always have to reduce. So I know, how did I know to divide both sides by 7? Well, because I know my multiplication facts. That's why you can't continue with this course unless you learn your multiplication facts. 35, or I know 7 times 5 is 35, and 7 times 9 is 63. So I know 7 goes into both of them. So if I divide both sides by 7, I get 5 over 9. So you're going to find the same thing in number 7. 5 times 8 is 40. 8 times 11 is 88. But I know my multiplication facts. I know 40 divided by 8 is 5. And again, division is just the opposite of multiplication, so multiplication facts helps even when you're dividing. 40 divided by 8 is 5, and 88 divided by 8 is 11. Remember, we learned the 11s for the multiplication facts. Again, I divided both sides by 8. I divided 40 by 8, and I divided 88 by 8. So sometimes in these problems, you're going to have to reduce. All right, so here's another one where you're going to have to reduce. But this says find the product of these two fractions. Now, what does product mean? Well, of course, product means multiplication. I'm going to make that a little smaller. So product means multiplication, so just set it up. 4/5 times 3/4. And go ahead and try that problem. Pause the video, and when you come back, we'll do it together. All right, we're back. 4 times 3 is 12. 5 times 4 is 20. But I know my multiplication facts, so I know if I divide both sides of the fraction by 4, 12 divided by 4 is 3, and 20 divided by 4 is 5, so 3/5. Again, we call this the fundamental principle of fractions, when you divide both sides of the fraction by the same number, or when you multiply both sides of the fraction by the same number. That's what I call the fundamental principle of fractions. All right, why don't you try number... Now again, if your answer was 12 over 20, that's correct. That's not wrong. It's just not put into lowest terms. You're going to get points taken off on a test or in school or when you look at the back of your textbook. If you're using a textbook, if you look at the back of your textbook, it's going to give this as the answer. It's not going to give this as the answer, so you're going to get confused. You need to reduce fractions to lowest terms. So try number 9, pause the video, and when you come back, we'll do it together. All right, we're back. 5 times 3 is 15. 8 times 5 is 40. But I know that I can divide both sides by 5. 15 divided by 5 is 3. 40 divided by 5 is 8. Final answer is 3/8. All right, number 10, what is 1/2 times 2/15? Times just means multiplication. That's just another way of saying multiplication. So go ahead and attempt this problem, and when you come back, we'll do it together. All right, we're back. 1/2 times 2/15. And by the way, you can write it as 2/15 times 1/2 or 1/2 times 2/15. It doesn't matter, because remember the commutative rule of multiplication. That works for fractions too. So 2 times 1 is 2, and 2 times 15 is 30. Actually, 2 times 15 is not one of our multiplication facts. But that's okay. What we can do is we can go ahead and just divide both sides by 2. And I know I'm going to get 1 over 15. But what we can also do is we can just keep it in factored form. You have 1 times 2 over 2 times 15. And then you can just cross out the 2's. Remember we did that before? And you end up with 1 over 15. So you can do it either way. But that's a problem where our multiplication facts didn't necessarily work. So we had to use the method where you keep things factored and then cross out the common factors. Again, that's from class 11. If you didn't do the homework, then you're really going to be falling behind at this point. All right, number 11, we're doing something different for number 11. Actually, we did it right at the beginning of the class. We're multiplying a fraction by a whole number. So in this case, what you do is you turn the whole number into a fraction. Whenever you have a whole number, you can always write over 1. So now it just becomes a multiplication problem. 2 times 3 is 6, or it becomes a multiplication problem like we did before. 2 times 3 is 6, and 11 times 1 is 11. It's that simple. Very easy. You know what? We should always leave the original problem. So I'm going to go ahead and rewrite that. You should always leave the original problem without messing it up. So you can go back and look at how to do the problem. All right, so same thing with this one. We got 2 times 3/8. We're going to change 2 to 2 over 1. And then 2 times 3 is 6. 1 times 8 is 8. And that can be reduced. Divide both sides by 2 and you got 3/4. The reason I say uh-oh is because I know that so many students are going to forget to do that. It's just a given. Alright, so why don't you attempt the next two problems. Pause the video, and when you come back, we'll do them together. Alright, we're back. So change 5 to 5/1. And it's just like the other multiplication problems. 5 times 1 is 5. 1 times 6 is 6. In number 14, change 2 to 2/1. And 4 times 2 is 8. 9 times 1 is 9. Very easy. All right, so up to this point, you can see that multiplying fractions is really easy if you don't have to actually apply the problem to the real world. I mean, the operation is really, really easy. You can teach a 5-year-old how to do this. As long as the 5-year-old knows multiplication facts, you can teach a 5-year-old how to do this in about 5 seconds. It really doesn't take that much. But now we're getting to some bigger numbers. So all this means is that reducing is going to be really difficult at the end, and multiplying is going to be a little bit more difficult. So 2 times, let's see here. I think I'm going to change that number to 17 just to demonstrate my point here. So if you multiply 2 times 15 is 30, and that's not one of our multiplication facts, but if you multiply 17 times 5, that's 35, carry the 3, 5 times 1 is 5, plus 3 is 8. Again, you should have learned this in previous courses. So 5 times 7 is 35, carry the 3, 5 times 1 is 5, plus 3 is 8. All right, so we get 30/85, but here's the problem. How do we reduce 30/85? Okay, that looks really difficult to reduce. And it is. I'm not really sure how to do it at this point. Well, I know how to do it, but I'm not sure what the answer is going to be. So what we do is we have to use the factoring method. So you have to factor 6 into, I know 6 times 5 is 30, but I can also factor it to 2 times 15 because we know we just multiplied 2 and 15 to get to 30. So I can factor 30 to 2 times 15. And 85, I have no clue, but I do know that 5 times 17 is 85. So I can just write 5 times 17. Now at this point, you're probably thinking, well, wait a second, didn't we just go backwards? And you're right, we did. I'm about to show you a faster way of multiplying when you have big numbers. But I'm going to show you the logic of it first. So now at this point, we take 15, because I know I have a 5 in the bottom. I'd like to have a 5 on the top so we can cancel out. Remember we canceled out the 2's up here? There's a 2 on the top and a 2 on the bottom. So I have 15, which is 3 times 5. So now we have a 5 on the top and a 5 on the bottom. So now I can cancel those out. Then I put the 2 and the 3 together to get 6. 2 times 3 is 6, and I'm left with 17 on the bottom. So 6/17. But again, as you can see, we went forward to 30/85. Then we went backwards to 2 times 15 and 5 times 17. So that's kind of counterproductive. So instead of just multiplying straight across and finding those huge numbers, there's a faster way to do it. Go ahead and write 2 times 15 without writing 30/85. Just write 5 times 17 and 2 times 15, and then go ahead and factor. So I know that 5 goes into 5 and 5 goes into 15. So remember, you can divide both sides of the fraction by the same numbers. So if we divide both sides of the fraction by 5, those 5's cancel out. And you're left with 6 over 17. So that's a much faster way to do it. There are actually faster ways. You can divide this number by 5 and you get 1. Divide this number by 5 and you get 3. So now it's 2 times 3 and 1 times 17. That's actually the fastest way to do it. But when you show students that method, they get kind of confused at first. So I'm going to just stick with this method here. But you can do it however you want to do it. But I don't want to throw too much at you at once. So now let's try the same thing. Let's keep it factored because 15 times 16, that's a big number. So let's keep the top factored and the bottom factored. So 8 times 3, 15 times 16. Again, we multiply the numerators to get the numerator of our product and the denominators to get the denominator of our product. So now I have a 3 and a 15. I know if I factor 15, it becomes 3 times 5. And I have an 8 and a 16. I know if I factor 16, it becomes 8 times 2. And how do I know that? Well, my multiplication facts. If you don't know your multiplication facts, man, you're really going to be hurting right now. So now I can cross out the 8's because there's an 8 on the top and there's an 8 on the bottom. And I can cross out the 3's. So there's nothing at the top, which means that it's just going to be a factor of 1. And it's 5 times 2 on the bottom, which is going to be 10. So again, you could multiply straight across. If you multiplied straight across, you would get, down here, you would get 8 times 3 is 24. And 15 times 16 is, let's see, that would be 160 plus 80, I think, is 240. So you could multiply straight across. You could do 8 times 3 is 24 and 15 times 16 is 240. You could do that. But now you've got this huge, well, it's the same fraction, but you've got these huge numbers that you have to reduce. 24 over 240. So now you have to go backwards and factor them to 8 times 3 and 15 times 16. So it's counterproductive. If the numbers become really, really big, it doesn't make any sense to go forward and then go backwards. So anyway, and again, the whole purpose of all that is just so that you can reduce. You can reduce without doing a lot of work. So now, guess what? It's your turn. Number 17. Multiply 7/8 and 2/3. So let's go ahead and set it up. 7/8 times 2/3, and it doesn't matter which way you do it. 2/3 times 7/8 is the same thing as 7/8 times 2/3. So again, you're going to have to reduce in this problem. So instead of multiplying and getting 7 times 2 is 14 and 8 times 3 is 24, go ahead and just write it in factored form, 7.2 and 8.3, and then continue to factor until you can cancel out like terms. Pause the video and attempt this problem, and then when you're done, we'll do it together. All right, we're back. So we're going to keep it in factored form. So the numerator of our product is 7.2, 7 times 2, and the denominator is 8 times 3. I'm going to make that a little smaller so I can fit it in here. So now we still don't have any common factors in the top and the bottom. So let's factor 8 to 2 times 4. So now we've got a 2 in the top and a 2 in the bottom, so we can cancel those out. And we end up with 7 over whatever 4 times 3 is. 4 times 3 is 12. All right, now we're getting to really big numbers in 18. Why don't you attempt 18, pause the video, and when you come back, we'll do it together. Remember, you have to know your multiplication facts. All right, we're back. So these numbers are so huge, if I multiply, I get 210 over 450 plus 90 is 540. Then I have to then go backwards and factor them again to get 5 times 42 over 12 times 45, and then so it's just counterproductive. So we're going to keep it in factored form. Five times 42 over 12 times 45. So let's see here, what can we do? I know 42 is 6 times 7 because I know my multiplication facts. And I know 12 is 2 times 6. There we've got common 6's now. And I know that 45 is 9 times 5. Again, because I know my multiplication facts. So now you got a 5 on the top that crosses out and a 5 on the bottom. And a 6 on the top and a 6 on the bottom. So you're left with 7 on the top. And 2 times 9 is 18 on the bottom. Again, you have to recombine the numbers. Recombine the 9 and the 2 when you write your final answer. So again, we got 210 over, what was it? 210 over 540, something like that. 210 over 540 reduces to 7 over 18. We just reduced it in the easiest way possible. All right, try number 19. When you come back, we'll do it together. All right, we're back. 27 times 40, so just write it in factored form. I think I'm going to write in smaller or thinner ink here because these are going to be big numbers. 27 times 40 over 64 times 81. 27 is 3 times 9. 40 is 5 times 8. 64 is 8 times 8. 81 is 9 times 9. We've got, now here's an important point. You've got 8s in the bottom and 8s in the top, but you can only cancel out one 8 in the bottom because there's only one 8 in the top. Same thing with the 9s. You can only cancel out one 9 in the bottom and one 9 in the top because there's only one 9 in the top. And at that point, we get 3 times 5 over 8 times 9. But I kept it in factored form because I realized the 9 can still be factored to 3 times 3. And we have a 3 in the top. So this was kind of a big one to give you here to do on your own. So 9 is 3 times 3. And 2 more 3's cancel out. So you're left with 5 on the top. And 3 times 8 is 24 in the bottom. All right. So let's go to the next one. Pause the video, attempt number 20, and when you're done, we'll do it together. And by the way, if you didn't do 19 correctly, that's okay. Just look back and figure out what you did wrong, and then we'll go on to the next one. All right, we're back. 49 times 5. And again, these are big numbers, so that's why we're not just multiplying straight across. We're keeping them in factored form. And 50 times 7. 49 is, I know I have a 7 on the bottom, so I'd like to factor 49 to get some 7s, but I know for my multiplication facts, 49 is 7 times 7. 50 is 5 times 10. And I could factor 50 to 2 times 25, but that would just make it longer because then I have to factor again. I have to factor 25 to get 5 times 5, so I'm just doing it the easiest way possible. Now, I can only cross out one 7 in the top because I only have one 7 in the bottom. And the 5's, of course, cancel out, and I'm left with 7 over 10. So if I multiply these straight across, I would get 245 over 350. 245 over 350. But then I would have to go backwards and reduce, which is pretty much what this already is, to figure out how to reduce the fraction. And that would be going in the reverse direction. So we just do it this way and we get to the answer as quickly as possible. But again, the most important thing to remember is when you multiply fractions, you're just multiplying the numerators and multiplying the denominators. Multiplying the numerators and multiplying the denominators. All right, so let's go to some easier problems here. But we're going to actually apply these problems in the real world. So that's when things start to get really, really weird. Again, the actual operation is easy. Well, this factoring stuff wasn't easy because I gave you such huge numbers. But the operation of just multiplying numerators and multiplying the denominators, that's really easy. It's only the reducing the fraction to 7/10. That's the hard part. But the operation is fairly straightforward, but understanding the operation is not straightforward. That's where things get weird. So let's see here. Let me move this down a little bit. I realized that wasn't lined up. All right. So you gave your friend 2/3 of a candy bar, but he ate only 4/5 of what you gave him. What fraction of the entire bar did he eat? So this is pretty much exactly the same thing as the 2/3 of a pound of spaghetti. In fact, I think these are actually the same numbers. So this is just a different application. Before you were talking about a pound of spaghetti was the whole figure. Now you're talking about a candy bar. So this is just a multiplication problem. I'm not gonna. What you're doing is you're finding a fraction of 2/3. You're finding 4/5 of 2/3 because you gave him 2/3 of the candy bar, but he only ate 4/5 of what you gave him. This is where interpreting this gets really involved. He gave you 2/3 of the candy bar. The candy bar represents the whole. That's everything. But he only gave you 2/3 of the candy bar. And he only ate 4/5 of what you gave him. He only ate 4/5 of the 2/3. So you're finding 4/5 of 2/3. That's interpreted as multiplication. 2/3. I'm going to go to the bigger ink here. 2/3 times 4/5. 2 times 4 is 8. 3 times 5 is 15. So we found 4/5 of 2/3. But how do you interpret this? The most important thing to understand, obviously, is what we actually found, and that is we found that he ate 8/15 of the entire candy bar. 8/15 of the entire candy bar. So 8/15 of the bar. Now again, I know what you're thinking. You're thinking that stuff seems really involved. It's really complicated. Well, everybody in the world thinks the same thing pretty much when it comes to this. So you're not alone. So again, you gave your friend 2/3 of a candy bar, but he ate only 4/5 of what you gave him. In order to find what fraction of the entire bar he actually ate, you multiply those fractions. So he ate 8/15 of the entire bar. Now again, we're not looking for what fraction of the part that we're not looking for what fraction of the part that you actually gave him. We already know that. We know that he ate 4/5 of what you gave him. Okay, that's not what we're looking for. That's easy. We were already given that answer. We know that you gave him, we know that he ate 4/5 of what you gave him. That's not what we're looking for. What we're looking for is what fraction of the entire bar did he actually eat? So if he ate 4/5 of the 2/3, then the fraction of the entire bar that he ate was 8/15. Again, this stuff is not easy to interpret. Let's see here. All right. I'm going to do number 22, and then you can do the next two word problems on your own. A boy was given 3/4 of a pound of hamburger meat for lunch, but he ate only 8/9 of his lunch. What fraction of a pound of meat did he eat? All right, so he was given, this is the same thing as the spaghetti problem. A boy was given 3/4 of a pound of hamburger meat for lunch. So that's what he was actually given for lunch, 3/4 of a pound. But he only ate 8/9 of that 3/4. So what we're looking for is what fraction of an entire pound did he actually eat? Again, we're not looking for what fraction of his lunch he ate. That's not what we're looking for. We know that he ate 8/9 of his lunch, right? We're not looking for that. We're looking for what fraction of an entire pound did he eat. So if he was given 3/4 of a pound and he only ate 8/9 of the 3/4, then that'll give us the fraction of the entire pound that he actually ate. So 3/4 times 8/9. And so you're probably thinking, well, why do I even care? I mean, I know it's just going to be multiplying fractions. I don't have to think about it, right? Well, you have to think about it in terms of what you're actually finding. So 3 times 8 is 24, and 4 times 9 is 36. But I know that I can reduce that if I divide both sides by 6. 24 divided by 6 is 4, and 36 divided by 6 is 6. But I can actually go further. Divide both sides by 2, and you get 2/3. So he ate 2/3 of a pound. He didn't eat 2/3 of his lunch. We already know what fraction of his lunch he ate. We know he ate 8/9 of his lunch. That's not what we're looking for. What we're looking for is what fraction of a pound he actually ate. 2/3 of a pound. Remember, in the word problems, you have to actually explain what you're looking for. So most teachers in this case, they don't even talk about what this stuff actually means. And I hesitate to even talk about it, to be honest with you, because I want to go as fast as possible here so you don't get bored and change the channel. But you really have to know what you're finding, or else you're just going to be lost. Because when we get into division problems, you're going to find that it's not easy to determine whether or not you're supposed to do a division problem of fractions or a multiplication problem of fractions. So now go ahead and attempt 23. So you know it's just going to be 3/8 times 2/5. It's not that big of a deal, but you have to interpret the problem. Lucky for you, it actually says, what fraction of the entire mural did you paint? So you know it's just going to be whatever the answer is of that fraction of the entire mural. So you know what to do. So go ahead and just do this problem, pause the video, and when you're done, and remember, you have to say what you're finding. So the fraction, and then you have to say of the mural. Pause the video, and when you come back, we'll do it together. All right, we're back. So 3/8 times 2/5 equals 6/40. And if I divide both sides by 2, that's not our multiplication facts, but if I divide both sides by 2, I get 3/20. 40 divided by 2 is obviously 20. Again, that's not a multiplication fact, but that should be fairly obvious. So you painted 3/20 of the mural. That's 3/20 of the entire mural. Again, we're not looking for what fraction of the job you painted. We're not looking for what fraction of 3/8, because we already know that that's 2/5. We don't care about that. We know that you did 2/5 of the job. The job is what both you and your friend are going to paint. That's the job, just that portion. We already know it's 2/5. We don't care about that. We're asking what fraction of the entire mural did you paint, and that's 3/20 of the mural. Again, the operation was easy. It was so easy to multiply 3/8 times 2/5. No big deal. We just had to reduce once, and we were done. But what does it actually mean? Again, and all the previous stuff that we've done, it's been really easy to figure out what it actually means, but not now. Multiplication of fractions is pretty involved. So why don't you try number 24? Number 24 is going to be multiplying a fraction by a whole number. This one is actually going to be easy to interpret. So go ahead and try 24, and when you come back, we'll do it together. All right, we're back. Each cup at the party held 2/13 of a quart of juice. So each cup holds 2/13. If there were 5 cups filled, what fraction of a quart of juice was used? So that's 2/13 is each cup. That's how much each cup holds, and there are 5 cups. So 2/13 times 5. So remember, when you do this one, you just put 1 under the number. And maybe we should have done this one together, because I forgot it was going to be a whole number. But and then multiply straight across. If you forgot to put the 1 under the 5, go ahead and just do that now. And pause the video and attempt this problem yourself. 2 times 5 is 10, and 13 times 1 is 13. So this one was pretty easy because we're just taking 2/13 and adding it 5 times. And so on. So the final answer is 2/13 of a quart. 10/13 of a quart. And you can say of a quart of juice or whatever, but we don't have a lot of time, so I'm going to say of a quart. All right, so now we go on to division. So if you thought multiplication was hard to understand, then wait till you get to division. Division is going to be even harder to understand. Now, the algorithm is really easy. But let me explain why division gets a little bit difficult to understand. So let's say you have 3/4. I'm just going to take an example here. In fact, I'm going to move this down. So I can use an example. So put example. So let's just take 3/4 as an example. 3/4 divided by 2. Now that's pretty straightforward. That makes a lot of sense because you're just taking 3/4 and you're dividing it into 2 equal parts. So if you do that, and you could probably figure that out on your own but you have to use geometry. Geometry is the only way to figure it out. So you take 3/4 and you divide it into 2 parts. So 3/4, that would be, it'll look something like that. That's 3/4. And you want to divide it into 2 parts. So you're going to cut 3/4 into half, or into 2 halves. So that's just like that. And then you end up with 1, 2, 3, 4, 5, 6, 6/8. But you only want half of that, right? So you're dividing into 2, and you get 3/8. So the new fraction is 3/8. And you can explore that further if you want, but the point is half of 3/4 is 3/8. That's pretty easy. You're just taking 3/4, like if it's 3/4 of a pound of spaghetti, you're just taking divided in half, and you'll find that it's 3/8. If you do the geometry on that, you'll find it's pretty straightforward. In fact, I'm going to leave that. But here's the problem. Well, let me take this, move it over a little bit. So that was example 1. Now let's do example 2. Example 2 is when things get weird. So let's do 2 divided by 3/4. Sorry, it's taking me a while to do this. Example 2, 2 divided by 3/4. So now, here you were just taking something and dividing it into 2 equal parts, right? But now you're dividing by 3/4. What in the world does that mean? What does it mean to divide something into 3/4 parts? Well, it doesn't really have a meaning at all in the real world. It doesn't make any sense. Now, mathematicians are going to scream at the top of their lungs that what I just said is blasphemous. How dare I say something like that? It always has a meaning. Well, no, it doesn't always have a meaning. Okay, dividing by a whole number, that has a direct meaning, but dividing by a fraction in the real world, what does that actually mean? Well, stop and think about it for a while. I dare you to stop and think about that for a while. Really think about it and see if you can explain it. And what you're going to find is that the operation starts to lose meaning when you're dividing by fractions. But mathematicians do use some complicated logic to try to explain. I'm going to go ahead and keep that, I guess. To try to explain what the operations actually mean. You don't have to think about that now. But it's basically, it's the commutative rule of multiplication and using the reverse of multiplication and so on and so forth. But again, almost nobody in the world understands why this math is used. And even mathematicians have a hard time explaining the logic behind it. So you, an elementary school student or whatever student, you could be a 50-year-old or a 5-year-old. If you're doing this stuff for the first time, you're not required to explain this stuff. You're just required to do it. And when we get into the word problems, you're probably thinking, well, what about the word problems? Don't I have to know what I'm doing? Well, when you get to the word problems, I'm going to show you a way to figure out how to interpret what you're doing, so don't worry about that now. But here's the algorithm. Again, I have good news. The algorithm is easy. What you're going to do is you're going to change the division sign to multiplication, and you're going to flip the divisor. Remember, this number is called the dividend, this number is called the divisor, and the answer is going to be the quotient. So you flip the divisor, always the divisor, it's always this one, never flip this one. So it becomes a multiplication problem. And there you go. So now we're multiplying 3/8 times 5/2, and that's really easy. 3 times 5 is 15, and 8 times 2 is 16. So again, the algorithm for division is really easy. It's not as easy as multiplication, but it's still pretty easy. But when we interpret what it actually means, that's where things get difficult. All right, so again, 2 steps. Change the division sign to multiplication and flip the divisor. I flipped this number. So now it becomes a multiplication problem. 5 times 5 is 25. 7 times 4 is 28. And both these fractions were reduced to lowest terms, so you don't have to worry about you don't have to worry about that on these problems. All right, so as you can see, it's pretty easy. Try number 27, pause the video, and when you come back, we'll do it together. All right, we're back. Change the division sign to multiplication, flip the divisor 3 times, and it becomes a multiplication problem. 3 times 1 is 3, 2 times 2 is 4. All right, let's go on to 28. Go ahead and try that problem, and when you're done, we'll do it together. All right, we're back. So change the division sign to multiplication, flip the divisor, then it becomes a multiplication problem. Multiply straight across. 3 times 9 is 27. 4 times 8 is 32. If you don't know your multiplication tables, you're going to be hurting at this point, and we can't reduce that. Wait a second. Yeah, that's right. 3 times 9 is 27, and yeah. So as you can see, the algorithm for division is pretty easy. Now let's go on to whole numbers. We have 5/7 divided by 2. That's a whole number. So what do? We do the same thing we did for multiplication. You change 2 to 2 over 1. So all we do is we just change the whole number to a fraction. 2 became 2 over 1. That you can always do that with whole numbers. It works every time. So now it's just a division problem. What do? There's 2 steps. You change the division sign to multiplication. You flip the divisor. It was 2 over 1, but now it's 1 over 2. And you multiply straight across. 5 times 1 is 5. 7 times 2 is 14. All right, let's try it again. So we're dividing by a whole number, so you just change 3 to 3 over 1. Then you've changed the division sign to multiplication, and you flip the divisor, and then it becomes a multiplication problem. 4/9 times 1/3. You just multiply straight across in each case. So 4 times 1 is 4. 9 times 3 is 27. So now why don't you try 31 and 32. Those are going to be division by a whole number also. Pause the video, and when you come back, we'll do it together. All right, we're back. Change 4 to 4 over 1. Then it becomes a division problem, or it still is a division problem, obviously. It becomes a division of fraction problem, division of fractions problem. Change the division to multiplication, flip the divisor. Then it becomes a multiplication of fractions problem. 8 times 1 is 8, and 9 times 4 is 36. So if you got 8 over 36, you did it correctly. But there's one thing that we have to do here. We can divide both sides by 4 to reduce it. If you didn't do that, then that's okay. Because in these other problems, you didn't have to reduce. So if I don't do it, then I don't expect you to remember to do it. But you divide both sides by 4, and you get 2 over 9. But if you got 8 over 36, you did it correctly. If you got 2 over 9, then you were especially correct on that one. All right, 7/8 divided by 5 becomes 5 over 1. Change the division sign to multiplication and flip the divisor. And then it becomes a multiplication of fractions problem, so it's just 7 times 1 is 7, and 8 times 5 is 40. On this one, we don't have to reduce. All right. Let's see here. So let's do 36. 36, you are going to have to reduce on that one. We're going back to just regular numbers here. So pause the video. Attempt number 30 did I say 36? I meant 33. Attempt number 33, and when you come back, we'll do it together. All right, we're back. So change the division sign to multiplication. Flip the divisor. And it becomes a multiplication problem. 4 times 5 is 20. 9 times 4 is 36. And we have to reduce this. So if you got 20 over 36, you did it correctly, but we have to reduce. I know that 4 times 5 is 20, and 4 times 9 is 36. So if I divide both sides by 4, I get 5 over 9. All right, now another way that you could do that is by factoring and then canceling out the 4's and getting 4 times 9, or 5 over 9. But in this case, we know our multiplication fact, so that's not really necessary. Now, when we get to bigger numbers, it is going to be necessary. All right, find the quotient of 4/5 and 6/7. So that means 4/5 divided by 6/7. We're going to have to reduce on this one. So pause the video. Remember, you're going to have to reduce. And when you come back, we'll do it together. All right, we're back. Change the division sign to multiplication. Flip the divisor. Then it becomes a multiplication of fraction problems. 4 times 7 is 28. And 5 times 6 is 30. Now, I'm not sure what we can do here. I know 6 times 5 is 30. I don't really see anything as far as our multiplication facts. So what that means is we can go backwards. We knew that 28 was 4 times 7, right? So we'll just keep it in factored form. No big deal. All right, so we got 4 times 7. And I'm going to make these numbers smaller because I'm running out of room. Bear with me here. I'm making them smaller, and I'm reducing the size of this. I'm running out of room. All right, so now we don't have any common factors still, so we have to keep factoring. That's how I knew that I'd have to make this smaller. So let's factor 4 to 2 times 2. And again, why are we using dots here? Because dots are just easier to write rather than cross signs for multiplication. And 6 becomes 2 times 3. And there we go. We have 2 on the top and 2 on the bottom. Now we can only cancel out 1 2 on the top because there's only 1 2 on the bottom. So 2 times 7 is 14. And 5 times 3 is 15. So 14 over 15 is the final answer. All right. Why don't you go ahead and try number 35. You're going to have to reduce at the end. And when you come back, we'll do it together. All right, we're back. Rewrite the dividend. Change the division sign to multiplication. Flip the divisor. Then it becomes a multiplication problem. 3 times 5 is 15. 10 times 4 is 40. Now I know if I divide 15 by 5, I get 3. And if I divide 40 by 5, I get 8. Because I know my multiplication facts. 15 divided by 5 is 3. 40 divided by 5 is 8. So again, if you got to this point, you did it correctly. You just didn't reduce to lowest terms. Divide 3/11 by 3/5. So I'm going to set this one up for you. 3/11 by 3/5. Now, if you write 3/5 divided by 3/11, you're going to get the wrong answer. So be sure you set that up correctly. Whatever you're dividing by goes in the number to the right. That's called the divisor. So go ahead and attempt this problem, and when you come back, we'll do it together. All right, we're back. Flip the divisions, or change the division sign to multiplication. Flip the divisor, multiply straight across, and you get 15 over 33. But I know if I divide 15 by 3, I get 5. And if I divide 33 by 3, I get 11. So 5 over 11. All right. Again, I used the fundamental principle of fractions. I divided both sides by 3. 37. Now in 37, we're starting to get into some big numbers. So let's do this one together, and I'll show you that we're going to have to use the factoring method. We're going to have to keep the numbers factored. So 2 over 21. Change the division sign to multiplication. Flip the divisor. Then when we multiply straight across, we're going to get 14 over 84. But 84 is not one of our products. It's not one of our math facts. So we have to keep it in factored form. So let's, instead of writing 14 over 84, let's write 2 times 7 over 21 times 4. And I'm going to go down to a smaller pen size here. So now I've got 4 is 2 times 2, so that'll cancel out the 2. And I know 7 times 3 is 21, so that'll cancel out the 7. So 21 is 7 times 3. And again, if you're having a hard time with this, it's because you don't know your multiplication facts. You refuse to remember your multiplication facts. That's your fault. It's not my fault. If you're having trouble with this, you refuse to memorize your multiplication facts. That's you. All right? That's your problem, not mine. All right? So 21 is 7 times 3. And then reduce 4 to 2 times 2. Then we can cancel out the 7s, cancel out one of the 2's in the bottom because there's only one 2 on the top. If there were 2 2's in the top, then we could cancel out both of them. But there's only one 2 in the top, so we can only cancel out one 2 in the bottom. And there's nothing in the top except a factor of 1. So we can write that. I don't know why I wrote an extra dot there. We can write that as just 1, and the bottom you have 2. Wait, no, I forgot the 3. 2 times 3 is 6. So 1 6 is our final answer. So you see, again, when we're multiplying fractions, so you have to use this same method sometimes, the same method that we used before, the factoring method, to reduce the fraction. Again, we could have written it as 14 over 84, but that would have been really difficult to reduce, so we have to use this to reduce, the factoring method. So now, why don't you try number 38, and remember, you're going to have to use the factoring method to make it easy to reduce it. Again, you can multiply straight across, but the fraction is going to be, you're just going to have to go backwards to reduce it. So attempt number 38, use the factoring method, and when you come back, we'll do it together. All right, we're back. Change to multiplication, flip the divisor, multiply straight across, and you get 5 times 27. I'm using the factoring method. I'm keeping them factored. 27 becomes 3 times 9. And the 9's cancel out. And you get 15 over 17. Now, if for some reason that you do it incorrectly, let's say that you factor 27 to something else. Let's say you go too far and you factor 27 to 3 times 3 times 3, and there's no 3 in the bottom, then you can just recombine, or you can factor the 9 to 3 times 3. You can do you can do it a number of different ways, as long as you factor it to lowest terms and get 15 over 17. So just be aware that it is possible to go off track here. All right, 15 over 48 divided by 5 over 12. Go and attempt that one, and when you're done, we'll come back and do it together. All right, 15 over 48. Change the division sign to multiplication, flip the divisor, and becomes a multiplication problem. So we have 15 times 12 over 48 times 5. I'm going to factor 15 to 3 times 5. And I'm going to factor 12 to 3 times 4. And I'm going to factor 48 to 6 times 8. Well, I know the 5's cancel out at this point. But I know that so I'm going to rewrite it as 3 times 3 times 4. So I got rid of the 5. So I have 3 times 3 times 4 over 6 times 8. But I know that if I factor 8 to 2 times 4, then I can get rid of the 4. And if I factor 6 to 2 times 3, I can get rid of another one of those 3's. So 3's cancel out, 4's cancel out, and I'm left with 3 at the top. And 2 times 2 is 4 at the bottom. 3/4. All right, so if you did that one correctly, that was a big one. Pat yourself on the back. If you didn't do it correctly, that's fine. Just go back and figure out what you did wrong. And now we're on to number 40. Pause the video, see what you can do, and when you come back, we'll do it together. All right, we're back. Go ahead and make a division, divide your work there. 18 over 25, change division to multiplication, flip the divisor. Now we have 18 times 10 over 25 times 9. Factor the 18 to 9 times 2. Factor the 10 to 2 times 5. Factor the 25 to 5 times 5. And how am I doing this with the factoring? I know my multiplication facts. Cancel out the 9's, cancel out the 5's, and you're left with 2 times 2 is 4. Recombine, and 5 at the bottom, 4/5. So again, we know our multiplication algorithm. We know our division algorithm, which uses multiplication. We know the algorithms, and we're using, the only hard part about this is just that I'm giving you big numbers to deal with. So you're having to use the factoring method to reduce. If all I was going to do, if all we're going to do is show you the actual algorithm, we'd be done in about 5 minutes. It's really the reducing that's the hard part. And the hard part is word problems. So now we're getting into word problems here. So a worm crawled 5/6 of a foot per hour. If he crawled 3/5 of a foot, for how long was he crawling? So, like I said, applying division problems to the real world starts to become really weird, because the application is not exactly obvious. If you try to take division of a whole number and apply it to division of a fraction, the meaning doesn't really translate. But mathematicians, they just love to define everything. Everything has to be defined. So even though dividing by a fraction doesn't really make a lot of sense in the real world, mathematicians have come up with a meaning for it. So we have to translate that into something that actually makes sense. But I'm going to use to kind of interpret this for you. I'm going to show you a method to figure out how to do this, because with multiplication, it was kind of, as long as you knew it was a multiplication problem, it was really easy to figure out the answer. But when it comes to division, there's a possible there's a source of error here. There's a possible source of error, and here's what I mean. We could take this number. We know it's a division problem, so that we've got that much figured out. But we could take 5/6 and divide it by 3/5, but we could also take 3/5 and divide it by 5/6, but those are not equal. Those are not the same thing. So our answer is either going to be 5/6 divided by 3/5, or it's going to be 3/5 divided by 5/6, but we don't know which one it's going to be. So here's where we start getting into some more potential problems. What you'll see is students accidentally multiplying this problem, or they'll divide in the wrong order, because again, this stuff is hard to interpret as far as what's going on in the real world. So what I'm going to show you right now is something called the factor label method, which you're going to learn in probably chemistry courses or upper science courses. So what we're going to do is we have 5/6 of a foot per hour. So 5/6 of a foot per hour. So I'm going to write feet over hour, because it's 5/6 of a foot per hour. And this is just a way to figure out what order of the numbers we're going to use. This is not anything that really applies as far as actual numbers. So we have feet over hour. And I'm going to try dividing by the other number. Now the other number is just 3/5 of a foot. It's not 5/6 of a foot per hour. It's just 3/5 of a foot. So the units for this one are just feet. So it's like a whole number. So you put it over 1. And let's try to do this and see if we get the right answer, or the right units. So you change the multiplication, you flip, and just as we crossed out numbers here, we're going to pretend that these words are numbers or are factors, so we're going to cross those out, and you're going to end up with, actually we should probably put those together. So feet times 1 is just feet. Hours times feet is hours dot feet. The feet cancel out, and you're left with 1 over hour. But 1 over hour is not what we're looking for. We're just looking for hours. We're not looking for 1 over hours. So what that means is 5/6 divided by 3/5 is the wrong answer. So you're probably thinking, well, that looks really complicated, but this is the way that pretty much all scientists, mathematicians, and people in the world that actually use this stuff, this is actually how they actually figure out the correct answer when you're using fractions. Because fractions are hard. It's hard for everybody. It's hard for scientists, mathematicians, engineers. It's this stuff is difficult. So this is people want to figure out, well, how do I know which number to divide? Well, this is how they actually figure it out. And again, I know that this doesn't look easy. It looks like some pretty involved stuff, but I'm just telling you, this is how they figure it out. If when I give you a test or in the homework, you're going to have to figure out if it's division of fraction or multiplication of fractions, and you don't want to just roll the dice. You also don't want to roll the dice when it comes to figuring out which number to divide. Do you divide 5/6 or do you divide 3/5? Well, you're not going to know unless you use this method of the factor label method I showed you here. This is called the factor label method. And again, you're going to learn that in chemistry. So now let me show you what it looks like when you actually divide correctly. So instead of dividing feet per hour by feet, we're going to switch these around. We're going to take this and write it in front, feet, and we're going to write it over 1 because it's considered to be you consider it a whole number, divided by feet per hour. And now watch what's going to happen. So you switch the division sign to multiplication, you flip the divisor, and then you multiply straight across, so feet dot hour over feet, and look what happens. Feet cancel out and you're left with hour. That's what we're looking for. We're looking for how long was he crawling. In other words, how many hours. So now we know how to do the problem correctly, so now the rest of the problem is going to be really easy because we just use the division algorithm. So now we're going to do this in about 20 seconds because we know what to do. We're going to take the feet, which was this part, 3/5, and I probably should write that up there, divided by 5/6. So feet is the 3/5, divide that by 5/6, and it's just a long division algorithm. So 3/5, change the division to multiplication, flip the divisor. 3 times 6 is 18, 5 times 5 is 25, and that's our answer. So we had to do all that stuff to figure out if we divide 5/6 by 3/5 or if we divide 3/5 by 5/6. It turned out that this was the answer. And how did I know that? Because I'd used the factor label method. If you use the factor label method, you don't have to think about all the logic or lack of logic, I should say, when it comes to dividing by a fraction or all the complicated meanings behind the algorithms. You just use this method here, and it works every single time. This is how engineers and scientists actually do this stuff. That's how they know. So, again, you might think, well, you might complain about this and say, well, this looked really, really weird and difficult. But, I'm just showing you how everybody does it. And I don't want you just rolling the dice to figure out what the answer is going to be. You actually have to use this stuff to figure out how to divide the fractions. So this is a word problem. So it says, for how long was he crawling? And it's in hours, right? We know that it's in hours. So that's 18/25 of an hour. 18/25 of an hour. All right, so let's see here. On to 42. So again, do I divide 4/5 by 3/8 or do I divide 3/8 by 4/5? That's what we're going to have to figure out here. We know it's a division problem, obviously, because it's in the division part of the homework. That's one way to figure things out. Let's read the problem. Tomatoes cost 4/5 of a dollar per pound. If you pay 3/8 of a dollar for tomatoes, what fraction of a pound of tomatoes did you buy? So again, most people in the real world, if they see this problem, they'll just quit and find some help. They'll just look for a mathematician, or they'll look for an engineer or a scientist. And the engineer or scientist will think in his head, okay, well, you've got 4/5 of a dollar per pound, so it's a dollar per pound, and you've got 3/8 of a dollar, so your units are dollars per pound and dollars. So if you use the factor label method, dollars per pound, dollars over pound, LBS is pounds. If you divide that by dollars, then you end up with dollars over pounds dot dollars, and the dollars cancel out, and you end up with 1 over pounds. That's incorrect. We just want pounds. We don't want 1 over pounds. So the engineer or the mathematician is going to be thinking in his head, well, you can't do it that way. So that's not the correct way. So the only other possible way we can do it is by switching the order. So now it's going to be dollars divided by dollars per pound, and as you can guess, it's actually going to work here. But when you cancel out, you're going to end up with pounds. I'm going to go ahead and do it just real quick here. So change the multiplication, flip the divisor, multiply straight across, and you get dollars dot pounds, dollars times pounds over dollars, cancel out the dollars, and you end up with pounds. So the engineer is going to think, okay, well that's the correct way to do it. I need to take 3/8 and divide by 4/5, not the other way around, not 4/5 divided by 3/8. Again, how do engineers know this? Well, the way I just showed you, that's how they figure it out. I'm going to make this smaller here. So now that we know the right order, we can go ahead and divide, and it's going to be really easy. 3/8 divided by, I put a divider there. Always order your work. 3/8 divided by 4/5. Change the division to multiplication. Change the 4/5 to 5/4. Multiply straight across, and you get. I'm going to bring my equal sign straight down here. 3 times 5 is 15. 8 times 4 is 32. So now we want to figure out what our unit is. We can't just say 15 over 32. We have to say what we're counting. So in order to figure out what we're counting, a lot of students will say, well, I don't know what we're counting. I can't figure it out. Well, of course you can figure it out. It's right there in front of you. What fraction of a pound of tomatoes did you buy? So it's 15 over 32 of a pound. And that is the full correct answer. Again, if we had divided the other way, we would have got, if we divided 4/5 by 3/8 the other way, then we would have got 32 over 15. All right, so why don't you try number 43 and use the factor label method like we did here to figure out which way you divide. Do you divide 2/3 by 6, or do you divide 6 by 2/3? Because in this problem we have a whole number. So this problem is a little bit different because we have a whole number, but if you have trouble with the whole number, don't worry, we'll do it together. So go ahead and pause the video, and when you come back, we'll do it together. All right, we're back. You have 2/3 of a pie, and you want to divide it among your 6 friends. Now this problem actually makes sense. Now that I think about it, you probably don't have to use the factor label method for this one. You're just taking 2/3 and dividing it by 6. What fraction of the entire pie will each of your friends get? So you don't really need to use the factor label for this method, but if you did 2/3 divided by 6, then you were correct. That's the correct answer. This one actually makes a lot of sense in the real world, so I didn't realize it was going to be a whole number. But if you use the factor label method, then you should have gotten fraction of the pie instead of 1 over pi. And when I say pi, I mean an actual pi, not 3.14 pi, if you know that number. So now we change it. We change to multiplication. Or actually, before we change to multiplication, we write 6 as 6 over 1. And then 2/3, you change it, the division sign to multiplication. You flip the 6, and it becomes 1/6. And then you multiply straight across. 2 times 1 is 2. 3 times 6 is 18. And you can divide both sides by 2. 2 divided by 2 is 1. And 18 divided by 2 is 9. If you got 2 18s, you got the correct answer, but it's not in lowest terms. So you get a point taken off on a test if you do that. So now at this point you're thinking, well, what did we just figure out? Well, it's not that difficult to figure out what you just figured out, because it says right here, what fraction of the entire pie will each of your friends get? So we just figured out each friend will get 1/9 of the pie. 1/9 of the pie. I shouldn't use a capital P there. 1/9 of the pie. Actually, now that I think about it, this should be 1/9 of the pie per friend, for each friend. So this problem is a little bit different. If you use the factor label method, it would be 2/3. You're taking pi and dividing it by 6. So pi divided by your friends, and you get pi per friend. So pi changes to multiplication. Friends is just friends over 1. Pi is just over 1 also. So be 1 over friends. Multiply straight across. Pi times 1 is pi. And 1 times friends is friends. And you get fraction of a pi for every 1 friend. Pi per friend. So 1/9 of a pi per friend. So that's what we were looking for. So that problem was a little bit different. All right, so number 44. 44 is going to be like the other problems we did. So it takes George 5/6 of a minute to eat 1 cupcake. If he ate for 7/9 of a minute, what fraction of a cupcake did he eat? All right, so again, do we do 5/6 divided by 7/9, or do we do 7/9 divided by 5/6? That's the big question. So we have to use the factor label method here to figure out which order. So let's do 7/9 divided by 5/6. So 7/9 is it's 7/9 of a minute. So that would be minutes divided by, and then 5/6 is it's 5/6 of a minute for 1 cupcake. So that's 5/6 of a minute for every cupcake. So that's minutes over cupcakes. And this minute we can just consider to be a whole number, so we just write over 1. And if you divide that, it's minute over 1 times cupcake over minute. Switch to multiplication and flip the divisor as usual. That's just the algorithm that you learned. And you get the minutes cancel out, and you're left with cupcake. We actually did it correctly because we ended up with cupcake. That's what we're looking for. What fraction of a cupcake did he eat? If we ended up with 1 over cupcake, then that would be incorrect. So let's go ahead and keep that. So now we can go ahead and just do the math. So we know it's in the right order. It's not 5/6 divided by 7/9. It's 7/9 divided by 5/6. So go ahead and do the operation. Both of those can be divided by, actually I don't know if those can be divided by anything that we know. It's 42 is 6 times 7. So I guess we're going to have to go ahead and write that, go back and write that in factored form. So 6 times 7 and 9 times 5. Factor it further, we can get 7 times 3 times 2, because 6 factors to 3 times 2. And 9 factors to 3 times 3. Cancel out 2 of those 3's, and you end up with 7 times 2 is 14. Recombine. 3 times 5 is 15. 4/15 of a cup cake. So if he ate for 7/9 of a minute, what fraction of a cupcake did he eat? He ate 14/15 of a cupcake. All right. So now we have 4 more problems here. So in the last 4 problems, we're going to focus on the factor labeling method, because now See, what's going to happen in the test is you're going to see problems, and you're going to have to figure out for yourself if it's a multiplication problem or a division problem. That's number one. Then once you figure out which operation to use, you have to figure out if what order the division is. So if it's a multiplication problem, it doesn't matter what the order is, because the commutative rule of multiplication, you can multiply in any order. But with the division, you have to divide in the right order, or else you're going to get the wrong answer. All right, so let's use the factor labeling method to figure that out. And again, I'm just showing you the method that everybody actually uses to figure out how to do these problems. If they didn't have this method, they would probably be lost. So you're just doing it the same way that all the scientists and engineers and mathematicians and people in the world are doing it. Number 45, a turtle crawled 3/8 of a mile per hour. That's pretty slow, 3/8 of a mile per hour. If he crawled for 2/5 of an hour, how far did he crawl? So we're trying to look for how far he crawled. All right, so let's start messing with some numbers here. Let's assume that this is going to be multiplication. All right, so we have 3/8 of a mile, 3/8 of a mile per hour, and here we have hour. So if we assume it's a multiplication problem, then it's going to be mile per hour times hour, because this is mile per hour and this is hour, so it's mile per hour and hour. We're just assuming that this is multiplication. Again, we don't know if this is multiplication. We're just assuming that it is, and then we're testing it. So hour is considered to be a whole number, so you write over 1. Then when you multiply those, you get mile dot hour over hour, and the hours cancel out, and you're left with miles. So is that what we're looking for? Let's go back and look at the problem. How far did he crawl? How far is miles? Miles is distance. Hours is certainly not distance, so miles must be distance. So it turns out that we were lucky on that one. We got the right answer. So we used the factor label method to see that this is a multiplication problem. I don't know what happened to my other line there for equal sign. All right. So now I'm just going to show you some ways that will give you some possible options that will give you the wrong answer, or it'll tell you that it's the wrong way to do it. So that was using the factor label method for that one. So that was attempt number 1. Let's try attempt number 2 now. So it doesn't matter which way you multiply it, you're going to get the same thing. So for multiplication, you only need to try one attempt. But for division, it could be 3/8 divided by 2/5. In that case, it would be miles. And I guess I should have wrote those numbers above. 3/8 times 2/5. And this would be miles per hour divided by hours. And that would give you miles over hours times 1 over hour, because remember, hour is considered to be a whole number. And you'd end up with miles over hour dot hour, but the hours are both in the bottom. So hours don't cancel out, and you're left with miles per over hour. That's not what we're looking for, so we know that's wrong. Again, you're looking for just miles. The hours should cancel out. You're just looking for just miles, because that's what the problem is asking for. How far did the turtle crawl? All right, so we know that that's not the correct answer. So I'm just showing you this just to show you what it'll look like if you get something that's not the correct way to do it. So I'm going to try one more here, attempt number 3. And you might be thinking, well, why am I showing you the wrong way to do it? Well, I just want you to see what it looks like when you do it the wrong way. So now we tried 3/8 divided by 2/5. Now let's try 2/5 divided by 3/8. Actually, I got to write that smaller. 2/5 divided by 3/8. That would be hours divided by miles per hour. So hours is just going to be over 1. Change to multiplication, flip the divisor, and you end up with multiplying straight across. You get hour dot hour over mile. You can't cancel out any of those hours, because remember, if you cancel out hours, there has to be an hour in the bottom and the top. So hour over mile is not correct. So the second attempt this third attempt we made was not correct. So that's what it's going to look like if you choose one that's the wrong number. So this one was correct. Just turned out that the first one that we used was correct. So that tells us what to do. So we're multiplying. 3/8 times 2/5. 3/8 times 2/5. 3 times 3 times 2 is 6. 8 times 5 is 40. Divide both sides by 2 and you get 3 over 20. So 3/20. And what are we looking for? How far did he crawl? We're looking for miles, right? So 3/20 of a mile. That's how far the turtle crawled. So again, that looks like a lot of work, right? A lot of work to try to figure out or what operation to use. Again, when we actually figured out what operation to use, it was so easy. Look at this. It was so easy to actually do the problem. But the hard part about this is figuring out how do we do the problem, or how do we set it up. Remember what I said, that in this class, the algorithms are going to be really easy. Okay, that's this part. They were really easy. But trying to figure out the logic behind the algorithms, that's all this part here. All right, so see if you can do number 46. Use the factor label method to figure out how to do it. Is it multiplication? If it's multiplication, then you just multiply. If it's division, you have to figure out what order to divide. With multiplication, it doesn't matter what order. So 46, go ahead and attempt that one. Pause the video, and when you come back, we'll do it together. All right, we're back. So 3/4 of a mile in 1 minute. And if the plane flew 2/3 of a mile, let's see, how long was it in the air? So this is actually going to be a division problem. Let's see if I can do this quickly. So I'm just going to do it the right way. I'm not going to show you the wrong way. So 2/3, that's miles. And you're going to divide that by miles per hour, which is the 3/4. This is miles per hour. This is just miles. And so it becomes miles. You change the multiplication and you flip to hours over miles. And miles is just a whole number, so you can put over 1. And then it becomes miles dot hours over miles. And the miles cancel out and you're left with hours. So because that's what the problem is asking for, it's asking for how long, meaning how many hours, we know that we set it up correctly. And we know it's a division problem. Now if you multiplied these two, you would end up with mile over hour, mile dot mile over hour. So mile dot mile over hour is not hours. That's not what we're looking for. And if you divide it the other way, you would have ended up with 1 over hour. And then it would have been, you would have known it was incorrect. So now that we know the correct way to do it, 2/3, change the multiplication, flip the divisor. 2 times 4 is 8. 3 times 3 is 9. Now, what did we just find? We have to write the unit. And you're probably thinking, well, I've done enough work at this point. I don't want to do it. Well, you have to do it. How do we know what the unit is? Well, it's simple. It just says how long was it in the air. So that's hours. So it'd be 8/9 of an hour. All right, 8/9 of an hour. Why don't you try number 47? Now 47, just be aware, it's going to be 5/8 of an hour per midterm. So it's going to be hours over midterm for this one. Hours for one midterm. Instead of being miles per hour, It's going to be hours per midterm. So go ahead and try that one, and when you come back, we'll do it together. All right, we're back, so I'm going to show you the right way to do it. The right way is, oh man, I wrote paper. I meant to write midterm. I'm sorry about that. Midterm. So what fraction of his midterm did he complete after 3/7 of an hour? 3/7, that's in hours, right? And then you're going to divide by 5/8, which is hours per midterm. So you write hour over 1, and then it becomes hour over 1 times midterm over hour, and then you get hour dot midterm. And by the way, you don't have to write this last part. You can just go ahead and cancel this out because you know it's going to be top and bottom. Hours cancel out, and you're left with midterm. Now, is that what we're looking for? Are we looking for midterm? Yes, we are, because it says, what fraction of his midterm did he complete after 3/7 of an hour? So we're doing it the correct way here. So 3/7, change it to multiplication, flip the divisor, multiply straight across, 24 over 35. And can we reduce that? I don't think we can. So 24 over 35 of his midterm. He didn't complete his midterm. He just did this fraction of it. All right. The factor label method is going to be a little bit weird on number 48. So you can go ahead and attempt that one, but just keep in mind, when I say it's going to be weird, I mean it's going to be, let's see here. So it's going to be a parrot eats 5/8 of an ounce of carrots. A baby parrot eats only 1/3 of what an adult eats. So this is kind of weird when it comes to the factor labeling method, because it's going to be 5/8 ounces per adult. And this other number is just going to be what the fraction of adults so that's just going to be adults, and those are going to be your units. So keep that in mind. All right, go ahead and attempt that problem, and when you're done, we'll come back and do it together. All right, we're back. I'm going to go ahead and shrink that a little bit. If you did the factoring label method, then you'll find out that it's, let's see here. I got to figure this out for myself. So it's ounces per adult. This is actually going to be a multiplication problem, because when you multiply these two together, the adults are going to cancel out and you're going to be left with ounces. That's what we're looking for. What fraction of an ounce of carrots does a baby carrot eat? So it's a multiplication problem, so that's going to be easy. It doesn't matter what order we multiply. 5/8 times 1/3. 1 times 5 is 5. 3 times 8 is 24. So 5/24 of an ounce. And we can also look back and see if that actually makes sense. An adult parrot eats 5/8 of an ounce. If the baby parrot eats 1/3 of what the adult eats, then that's going to be smaller than 5/8, and 5 over 24 is smaller than 5/8, even though 24 is a bigger number. Now you might wonder why that is. Well, think about it. If you have a pizza, you divide it into 8 parts. Those parts are going to be bigger than if you divide a pizza into 24 parts, right? So 5 out of 24 is much, much smaller than 5 out of 8. All right, so we know we did that correctly. All right, what else do we have here? All right, I think that's it for this class. So, again, multiplying, this is the first part of the course where we're starting to get into some stuff that is fairly involved as far as the actual algorithms, but don't worry. This is, as far as understanding things, this is probably the hardest part of the course. The next classes are going to be a lot easier than this. So this is your homework. Get a screenshot of that. And then get a screenshot of this page. get a screenshot of this page, and a screenshot of this page, and a screenshot of this page. Actually, probably just get a screenshot of that and that. And as usual, I'm giving you the answers to your homework. And why am I giving you the answers? Because you have to check your answers. If you don't check your answers, then you're just wasting your time. You got to make sure that you did it correctly. And remember, you can't continue to the next class until you do the homework from this class completely and correctly and organize your work. Don't just put a bunch of slop on your paper. And you got to put your homework in your binder. You got to have your tests in your binder and your homework in your binder. Everything has to be ordered. So I'll see you in the next class, and I'll look forward to it.